Welcome back. Today we will be talking about the prerequisite for Exponential Algebra 2 and pre-calculus both, and that is exponents and radicals. You might have learned about the exponents and radicals in Algebra 1. So exponent is nothing but when we are talking about the power, right? Something to the power of something. Repeated multiplication can be written in exponential form. Sometimes it is tedious to keep on writing a times a times a times a. So the other way is to write as the power, which is a to the power of 5, because we are multiplying 5 a's together. Same way, negative 4 times negative 4, 3 times, so negative 4 to the power of 3. Now, another important thing is the exponent can also be negative. Again, this property, it talks about if we have a negative exponent, I can write as a form of a fraction. Right? So a to the power of negative m will be nothing but 1 over a to the power of m. So these are the properties that are basics that you have learned in Algebra 1, and we are just revisiting them again. So the first one, if the bases are same, how we can multiply the two exponents, right? So when the bases are same, technically we are adding the two exponents together, right? Remember, multiplication is with addition. Division will go with the subtraction. So whenever it is a fraction, a to the power of m divided by a to the power of n, that means we are subtracting the two exponents together, provided the bases are same. Now, another important thing, anything to the power of 0 will turn into 1, provided then a should not be 0. For example, if someone says, I have $1 million to the power of 0, that is nothing but just 1, right? Okay, now another property, number 5, it is nothing but distributing. So we are distributing m with a and m with b, right? So that power will be distributed. But with number c, it is a little bit different, because a to the power of m is in the parentheses and n is standing outside. So we are multiplying them together. The last one, number 8, it is in absolute value. These bars are absolute value bar. So a squared, absolute value of a squared is nothing but absolute value of a squared. I can redo the example in a different way. So negative 2 squared, I can write it down as the absolute value of 4, which is nothing but 4 again. Remember, absolute value, as we discussed earlier, whatever goes inside the bar will come out in a positive way. Now let's try to solve it. When they say negative 2 to the power of 4, we are multiplying them 4 times. Now this is different, because negative is outside, it is not in the bracket. So you are multiplying 2 to the power of 4 first, and whatever the answer is, that is combined with a negative. So be careful with these. Let's take this example. Now, we have the parentheses, right? And 2 is outside the parentheses. So we are using property number 5. So 5 to the power of 2, x will be 3 times 2, because 3 and 2, and y to the power of 2. So this will be your final answer. Now let's talk about something else, which is called scientific notation. You have learned about scientific notation in 8th grade. So when the numbers are big, it becomes tedious to keep on writing the zeros down. To make our life easier, we write in the scientific notation. When you have to plug all these numbers in the calculator, by default, calculator take it either as the error or gives you the answer in the scientific notation. So one thing you need to remember, that your number should be greater than or equal to 1 but less than 10. So anything greater than or equal to 1 and less than 10, that's what we are trying to achieve. So for this big number, we cannot take 359. We cannot write it as 35.9. I need that number to be between 1 and 10. So they wrote 3.59, right, which is less than 10. And all the zeros are taken as the power times 10 to the power of 20. Right? Less than 10. Now the another example, again it is 9, which is 9 is less than 10. Yes, it is in the scientific notation. So that is my clue. The number should be less than 10, then it will be a scientific notation. Now another crucial thing is the radicals. When we are talking about the radicals, there are certain things that you have learned in Algebra 1. They were true there, but we will go in detail. So this is the symbol of radical. And then we write small n. Small n indicates index. And whatever is there inside the radical, that is called radicand. So we are talking about little vocabulary about this whole entire symbol. So radicand, index, and this is the symbol of a radical. Now, it is a common misunderstanding that I can write the square root both negative and positive way. I know you have learned this way in Algebra 1, but this is a little bit advanced, right? We are progressing in mathematics more. So they are a little bit different. When we are writing radical of 4, the answer will be 2 only. If negative is standing outside, then only it will become negative 2. So stop the practice of writing radical 4 is equal to plus or minus 2. Don't do that. Because negative 4 is not a real number. It is an imaginary number, because you cannot take the radical of a negative number. When negative is there inside the radical, then that negative is the imaginary number, which is nothing but I. We will discuss about it in later videos. So these are the properties of radicals. The index, n is the index. When nothing is written for the index, right? If it is just the square root, we take it as the square root. We take it as granted. Now, when the indexes are same, I can combine the two radicals together, right? Either in the multiplication or in number 3, we are dividing them a over b because the indexes are same. Now, let's talk about number 4. This is very, very important. It looks crazy, isn't it? We have radical, and inside the radical there is another radical. But what they are talking about, let's multiply the two indexes together. That's it. Another thing, I can write radical 3 because radical is nothing but the power as the fraction. When we have the fraction as the power, that is a radical. So if I square it, what will happen? 1/2 times 2, it is 2 over 2, which is nothing but 1. You are left with only 3. That is the whole idea about the property number 5. If the index and the power, they are same, then it is the number itself. Let's try to simplify these. So the first one, radical 8 times radical 2. What are the factors of 8? 2, 2, and 2. It is a square root, so 1, 2 can come out and another 2 will stay, because square root means we are making a pair, right? We are talking about twinsies. This is one way of writing it down, because radical 2 times radical 2 will give you radical 4, which is 2. Or I can combine those two together in one big radical, and that will be radical of 16, and radical of 16 is nothing but 4. Now here, the exponent and the index, they are both same. So when the index and the exponent, they are same, we are just left with the number. So the answer is only 5. So always check what is the index, what is the power. Let's talk about C. So x to the power of 3 to the power of 1/3, because we are converting radical in the fraction exponent. And that will also be 3, because the index and the power, they are same. And the same thing goes with D as well. For D, you can also write as the absolute value of y. That is also fine, because the index and the exponent, it is an odd number. That is why it is an even number. That is why we can write as the absolute value. Now, rationalizing the denominators and numerators. So we have done rationalizing earlier in Algebra 1. The purpose of rationalizing is we don't technically like denominators to be in the form of a radical. To get rid of it, we rationalize it. We multiply numerator and denominator by the same common denominator more often. Sometimes we multiply with the numerator as well. With this, there comes something called conjugate. Conjugate means we are just when the two terms are involved. For example, in this case, we have a plus b times radical m. So two terms are combined together with addition or subtraction. So when we change the sign between the two terms, that becomes conjugate. So the conjugate of 5 plus radical 2 will be 5 minus radical 2. You are just changing the sign, the operation sign. We are not changing the terms. So we can use this in two ways. Rationalizing the denominator, when there is only one term in the denominator, then we only rationalize. Right? So with only one term in the denominator, just rationalize. But when we have two terms in the denominator, for example 5 plus radical 2, then conjugate first, and with that conjugate we will rationalize. So let me write it down so that you can take your notes. So when the two terms are there in the denominator, conjugate first, and with that conjugate rationalize. Rationalize means multiplying numerator and denominator by the same number. So a and b, they are first category. That means only one term is there in the denominator. So let's rationalize. Multiply numerator and denominator by radical 3. So this will give you 5 radical 3 over 6, because 2 times 3 radical 3 and radical 3 will give you radical 9, and radical 9 is nothing but only 3. I want you to try number B on your own. It is the cube root of 5. So you will rationalize by cube root of 5 in the numerator and cube root 5 in the denominator. Now number C, it has two terms. Now you might say, okay, denominator, we don't have any radical in the denominator, then why? Sometimes there will be a question where they want you to simplify it further. So what we will do, we will conjugate the numerator and then rationalize numerator and denominator both, even though you will get the answer in the form of a radical for the denominator. But they just want to simplify it, so we are doing the process. So when we conjugate this, it will be radical 5 plus radical 7. Remember, we are just changing the sign. So let's multiply numerator and denominator by radical 5 plus radical 7. Now to simplify this, if you remember, you have done the property a plus b times a minus b is nothing but a squared minus b squared. So radical 5 minus radical 7 is a minus b in this case, and radical 5 plus radical 7 is a plus b. So I can combine it and rewrite it in terms of a squared minus b squared. Radical 5 squared and radical 7 squared. Denominator, rewrite everything. Now what is radical 5 squared? Radical 5, that means the index is 2. It is just 5. And 5 minus 7. And 5 minus 7 is negative 2. And then we can simplify it further by cancelling out 2 and 2. So my final answer will be this. Negative 1 over radical 5 plus radical 7. I hope this is making sense. Now the final thing that we will discuss today is about rational exponent. I have discussed this earlier when we were talking about the radicals, but let's go through again. So we are talking about the index. Remember, the denominator is the index, right? And the numerator is the power. So I can rewrite it either as b to the power of mn, or radical with the index n, everything to the power of m. So all the three, they are nothing but the same thing. So index will become the denominator and the power will stay as the numerator. So in this case, 5 is the denominator. That means index is the 5. And 4 is in the parentheses inside the radical and everything cubed. The another way is I can do 4 cubed inside the radical with the index of 5. So these are different ways of writing the rational exponents. Let's try number A. So the denominator is 5, right? So the index is 5. So negative 32 and everything to the power of negative 4. So what are the factors of 32? So the factors of 32, we have 5 2's together. Negative 2, negative 2, negative 2, negative 2, and negative 2. And the index is 5. That means we are making a group of 5. So we are just left with negative 2. But the power is negative 4. Whenever we have the power as negative, it becomes a fraction. So I can rewrite in the form of a fraction. And then we can simplify it further. So 1 over 16th, that is your final answer. Because anything to the power of negative exponent will turn into a, we can rewrite it as a fraction. Now question number B is very, very interesting. We have talked about this property earlier. Right here, number 4. So what they are talking about, just combine the two indexes together. So the inside index is 2, right? And the outside index is 3. So because no number is there, that is why it is a square root. So we can write 3 times 2. Yeah. So 3 times 2, which is 6. So, but let's try to understand and solve it in a different way. If I may ask you, what are the factors of 125? Can we start factoring 125? If you start factoring 125, you will get how many 5s? You will get 3 5s. 5 times 5 is 25, and 25 times 5 is 125, isn't it? But they are talking about the square root. Is there any other way I can approach this problem more accurately? So let's write it down. So 5 and 25 is nothing but 5 and 5 again. Now we have a group of 3, isn't it? So we have a group of 3. Let's break 6 into 2 parts. So let's find out what is the cube root of 125, and whatever answer we will get, we will solve it further. So 5 cubed and 6. Can I write it as 5 to the power of 3 over 6? Because I can write as the rational exponent. Remember, the index will become the denominator. So the denominator is 6 and the power will be the numerator. And what is 3 over 6? 3 over 6 can be simplified as 1/2. And I can rewrite it as radical 5. This problem is very, very interesting. Because if you try to approach it, okay, let me find the square root of 125, you will end up with 5 radical 5, and then you have to find the cube root, right? So using different properties, these two different properties that I have highlighted, it will make sense. Thank you for watching, and make sure you like and subscribe. Bye-bye.